Welcome! Today, I'd like to introduce you to the MakerAI Delphi suite, a set of components designed to integrate the full power of generative artificial intelligence directly into your Delphi applications, 100% natively. No Python dependencies, no complex bridges, just pure Delphi. In this hands-on session, we will go step by step, starting with a simple chat and quickly scaling up to use advanced tools like computer vision, video generation, function calling, and much more. Let's get started.
Hello and welcome to all our friends in the Delphi community. I'm Sol, and today I'm incredibly excited because we're joined by Gustavo Enriquez to introduce something that's going to be a game changer, version 3.0 of the MakerAI Delphi suite. Gustavo, it's a pleasure to have you here.
The pleasure is all mine, Sol. Hello, everyone. I'm very happy to be able to show you what we call the ultimate AI ecosystem for Delphi. Today, we'll see what makes this suite so different for integrating artificial intelligence natively and robustly into our enterprise architectures.
Fantastic. Gustavo, to start, take us to the root of the problem. As developers, we see the advancement of AI, but integrating it isn't so straightforward, is it?
Exactly, Sol. The main challenge is fragmentation. We're facing a chaotic ecosystem of APIs. OpenAI, Gemini, Claude, Llama, Grok. Each one requires its own SDK, its own syntax.
Tell me about it. That creates a huge dependency. The code you write today for one model is obsolete tomorrow.
Totally. And for those of us who work with Delphi who value stability and longevity, having to constantly rewrite code is a simply unacceptable risk.
So, in the face of that chaos, what is the solution that MakerAI proposes?
We present what we call a universal connector for APIs. The philosophy is simple. You write your code once and use it with all models. Through a single unified interface, our TA chat connection component, we create an abstraction layer that shields your application from all that complexity.
So you mean, instead of worrying about the specifics of each model, I unify everything under one umbrella? Chat, video, audio, all together?
Precisely. Your Delphi application focuses on what it wants to achieve, not on the technical details of how a specific model does it. It's like a data access layer, but for the world of AI.
I love that analogy. Tell us a bit more about the heart of that architecture, the TA chat connection.
Think of it as a driver factory for AI. It's our central point of communication. We already include native and optimized drivers for the most important models like OpenAI, Gemini, and Llama.
And what if a new model comes out tomorrow?
That's where its true power lies, extensibility. Thanks to the TA chat base class, you can inherit and create new drivers for any future model. This ensures that your investment in code is protected in the long run.
Okay, unification is great for 95% of cases, but as a developer, sometimes I want to squeeze the most out of a model. What if I want to use a super specific feature of Gemini that isn't standard yet? Do I lose that control?
Excellent question, Sol. And the answer is no. We know that sometimes you need full control. For those cases, we've designed the suite so you have direct and transparent access to the specific driver. You can use classes like TA chat Gemini or TA chat OpenAI and configure those exclusive properties right before the call.
The best of both worlds. I maintain clean, universal code for day-to-day use, but I have the power to go low-level when I need to. Maximum flexibility without sacrificing compatibility.
Exactly. That's the idea.
Let's talk about resilience. What happens if I ask a model to do a task and it just can't do it? For example, I ask it to generate an image from a model that only processes text.
That's where our 3-level automatic fallback capability shines. Level 1 is native. The model supports it directly, the ideal case. Level 2 is the internal fallback. If the main model can't do it, the suite automatically uses another one that can, like using DALL-E if you're with OpenAI.
And if that fails too?
Level 3, the programmatic level, kicks in. Here, Delphi takes control through events where you can execute your own code. Call another API, process a local file, whatever you want. The suite injects that response back as if the model had generated it. The result is an always complete, uniform, and resilient interface for the programmer.
This connects to file handling, right? How does the suite manage, for example, a PDF or an image?
With the TA native input file and T output properties, the suite orchestrates everything intelligently. It knows if the model can process a PDF natively. If not, it activates the programmatic fallback we just discussed. And most importantly for us Delphi developers, no extra components are needed. Everything is managed centrally and cleanly.
Let's move on to productivity. Managing prompts can become chaotic. How does MakerAI help us?
We separate the prompt from the code with TA prompts. It allows you to create libraries of complex, versioned prompts with dynamic parameters. Additionally, we've implemented a robust 3-layer memory, the history of the current conversation, a secondary persistent key-value memory for user preferences, and the system message with the base instructions that remain constant.
This ensures the AI is coherent and maintains context. Goodbye to conversations that forget everything after 2 minutes.
Exactly. And so far, we've talked about a conversational AI, but the real revolution comes when the AI acts. This is where TA functions comes in.
The famous function calling. Tell us how it works in the suite.
Imagine a user asks, what's the status of order 123 and the stock level of the main product in that order? A normal AI wouldn't know what to do. With TA functions, you, as a developer, expose secure functions from your application, like get order status or get stock level.
And the AI uses them?
Correct. The AI analyzes the question, understands it needs to execute 2 actions, calls your Delphi functions with the right parameters, gathers the information, and finally gives the user a coherent answer in natural language. We transform the chatbot into an active work agent, integrate it into your business processes.
Wow, that connects the AI to the inside of the company. And what about connecting it to the outside world?
For that, we support the MCP, Model Context Protocol. It's an emerging standard for AI tools. The revolutionary thing here is that thanks to our implementation, even a free local model running on Ollama can suddenly interact with your Google Calendar, browse a website, or manage files. It democratizes access to external tools.
Gustavo, a key point in enterprise environments is specific knowledge. How do we make the AI understand our data?
This is where our RAG 2.0 engine makes a huge difference. We start with RagVector, which is based on semantic searches. It converts your documents into numerical vectors that capture meaning. So when you search, you're searching by idea, not by keywords.
And I assume, following the suite's philosophy, we're not tied to a single provider for embeddings or vectors, right?
Of course not. We support multiple providers, and you can switch engines without changing a single line of your search code.
And where is the quantum leap you mentioned?
It's in RagGraph. This component is incredibly flexible. It can work as a hybrid RAG system, combining semantic search with a knowledge graph to understand how documents are connected.
And its other function?
It can also function as a traditional knowledge graph, a very powerful tool for analyzing structured data. You can model the complex relationships of your business and ask questions like, find the shortest path between this supplier and our end customer, or identify the employee who is the sole bridge between sales and engineering.
It's the perfect union of unstructured knowledge, like documents, and structured knowledge, like business relationships.
With all these tools, we make the leap from reactive AI to proactive and autonomous AI with Taya Agent Manager.
An agent orchestrator sounds powerful.
It is. It allows you to design complex workflows where multiple AI agents collaborate. You can chain an agent that uses RAG to research, another that uses functions to act on the company's systems, and a third that consolidates the results. It's about creating collaborative AI systems, all orchestrated from Delphi.
All this power needs a human interface. What about voice interaction?
For that, we created the TA Voice Monitor. It's a cross-platform component that offers a complete voice experience with real-time speech-to-text, background noise detection, and, most interestingly, keyword activation.
Like Alexa or Siri, but implemented directly in my Delphi application.
Exactly, to create natural and frictionless voice interactions.
And to close the loop, the visual interface. What components do you offer?
We offer a complete and professional UI experience. We have Thai Chat Bubble to display text and multimedia, Thai Chat List to manage the conversation thread, and Thai Chat Input, which integrates text, attachments, and the voice monitor.
So in a demo, we could see how you can switch models in real time, ask for an image, a multimodal response, and everything appears fluidly in the chat.
It's the culmination of everything we've talked about, a powerful, fluid, and fully integrated user experience.
Gustavo, this has been an incredible presentation. In short, MakerAI Delphi 3 is not just another library.
No, it's a complete ecosystem that turns Delphi into a first-class AI platform. It offers a universal architecture that protects your code and super powerful tools like RAG 2.0 and autonomous agents to build the next generation of enterprise applications.
The potential we now have in our hands is enormous. Gustavo, thank you so much for your time and for this very clear explanation.
Thank you, Sol, and thanks to the entire community for your attention.
And to you, fellow developers, we hope this has opened up a new world of possibilities. Until next time.
Let's jump right into the demo to see all the features of MakerAI Delphi Suite in action.
To save some time, we already have the layout for a simple chat setup. We have a prompt area, a response area, and a button to execute the query. Currently, we are working in synchronous mode, which means the Windows interface will freeze momentarily while we wait for the AI's reply. As you can see below, there is no AI code written yet, just the basic framework. Let's connect a local AI using Ollama. This runs autonomously on my machine. We find the component TAI Ollama Chat in the component palette and add it to the form. The key setting here is the language model. We'll be using the GPT-OS model with 20 billion parameters. Moving on to the code, inside the button event, we create two variables, the prompt and the result. We pull the text from the prompt memo and call Ollama like this. The result is assigned by executing the component. We pass in the prompt, the user role constant, and an empty list for attachments since we don't need any right now. Finally, we append the response to the output memo. And that's it. Let's run the application and check the result. In the chat, we type, "Hello, how are you?" into the prompt area. When we press the send button, the system responds using the local model on our machine, as you can see on the screen. Now, let's make some changes. Instead of using Ollama directly, we'll use our AI Chat Connections component, which allows us to connect to all available models. We'll implement a system so the user can choose the provider, which we'll call the driver name, and the model. First, in the onCreate event, we call the getDriversNames function, which returns a list of available providers. We assign this list to the drivers combo box. Next, we move to the onChange event of the combo drivers to assign the selected driver to the chat and populate the models combo with the available options. For convenience, we always sort both the drivers and the models to make them easier to find. Finally, in the models combo onChange event, we assign the selected model to the chat. That should be enough. Let's compile and test. Okay, we missed something important here. We need to add the models we want to work with to our library list. In this case, we'll add Claude, Ollama, OpenAI, Gemini, DeepSeek, Mistral, and LM Studio. Now we are ready. Let's compile again. We select the driver first and then the model. As you can see, we have now enabled our chat with the ability to freely switch between both drivers and models. We'll start by testing with Claude and the Sonnet 4.5 model. We ask for the model's name, and we can see it identifies itself as an anthropic model. Now we try with DeepSeek and ask the same question, getting its respective company as the answer. Finally, we'll test with Gemini and its latest model, Gemini 3 Pro, and get its response as well. Now let's move on to using functions. MakerAI has the capability to use internal functions, which we'll refer to as function callings, as well as external functions via a protocol called MCEP. In our example, we'll focus solely on function callings. To do this, we find the component named AI Functions in the component palette and add it to the form. Once added, we link it to the chat using the chat.aifunctions property. Functions are added via the Functions property, which opens an editor. The first setting to change is the function name. In our case, we'll call it getSystemDateTime, and it will be responsible for returning the system date and time. We must provide a concise and clear description. Although our example function doesn't require parameters, for compatibility reasons with certain models, we'll add a dummy parameter with an equally clear description. Finally, we need to implement the event required to execute this function. Inside it, we assign the response to the toolCall.response variable, in this case, the system date and time as text. Oh, and we mustn't forget to enable function calling on the chat before making the request. We do this by setting the toolActive parameter to true. Let's compile and test. We'll use Claude first, we ask for the date, and we see that the model now has access to our local function. Let's try again with OpenAI. We ask the same question and get the correct answer. It's worth noting that MakerAI provides this functionality provided that the model supports this type of calling.
From now on, we'll use a demo included with the source code called Chatful. Let's compile it and test out some of the advanced chat features. The first feature is asynchronous mode. In this mode, the model responds progressively, making the user experience much smoother. Before making the request, we'll switch the reasoning level to low to get faster responses. Now we ask, "How are you?" The model will first take some time to reason and then respond bit by bit, allowing us to watch the entire process in real time. On the screen, we can see the complete workflow, including the reasoning phase. For the next exercise, we'll use ChatGPT 5.1 and ask it to describe an image. We simply use the MakerAI utilities to attach files. By selecting the Upload Files option, we browse for the file, attach it, and then ask for the description. Just like the previous request, the model will reason briefly and then progressively generate the description of the image. The best part is that since the response remains in the context, we can ask it to translate it into another language, for example. Moving on with the features, it's possible to request responses in clean JSON format, that is, without any additional text. We select the JSON format option and ask it to generate the description in this format. There's the response, being generated asynchronously and correctly structured, ready to be used by our programs. However, not all models have the capability to generate native JSON. One of the features MakerAI offers is the ability to extract text blocks, such as JSON, HTML, MD, etc., from the content. This isn't a model feature, but a component one. It extracts the text and presents it as attachments. To do this, we check Extract Text Files, and that's enough. The model generates the normal text, but an attachment appears with the requested data. In our example, we ask for a JSON, and upon opening it, we can see the generated JSON response. The next feature is web search, which is also offered by some models. We use OpenAI's GPT 5.1 and select web search. When we ask a question, we see the results being generated, and at the end, the list of links or sources appears. Since the text is long, we could ask it to summarize it as needed. We could also ask it to generate the response in JSON, allowing us to get the result in a format our programs can interpret. Then we have the code interpreter feature. This allows the model to rely on code generation, whether to create responses and files or to process inputs like Excel or CSV files. In our example, we'll tell it to generate a .wav file with a 450 Hz tone. We make the request and wait a moment for it to generate and return the file. The model might take a little time as it has to generate the program, execute it, and finally return the file. And if the file is large, downloading it will take a bit longer. Now, if we open it, we can hear the pure tone. But it's not just for audio. Let's try an example of a Cartesian chart with random points. We send the request asking it to generate a chart with 100 random points. We wait a moment for the response, and there it is, an attached file in the requested format with the necessary information. At this point, we could upload an Excel or CSV file with data, and the model would be able to return the generated chart. Since this is one of my favorite features, let's do a third example. We'll ask for a Word file with a research template. We'll tell the model to generate a template for a university research outline.
We send it, wait a moment for the file to be generated, and it's done. Upon opening it, we see it generated the Word file perfectly with the requested structure. I want to emphasize that all of these are native model functionalities and only require parameterization to implement. No additional code is needed.
Now we'll see one of the most amazing features AI has to offer: video generation with audio included. In this example, we'll use Gemini Veo 2 Plus. So we select the Gemini driver and look for the Veo 2 model. We'll ask it to generate a video of a Spartan warrior programming in Delphi, and let's see what this model is capable of. It's worth noting that video generation can take quite a while, and there are variations, such as generating a video from an image, among other options. Once the video is generated, we open it and see the Spartan warrior working on something resembling a tablet. Since the context was limited, we can see the model used its creativity to imagine the environment. Along with video generation, we have image generation with the advanced models offered by Gemini 3, as well as OpenAI. In this case, we'll use Gemini 3. We'll ask for something similar. Generate an image of a Spartan warrior, but in a high-tech environment, and we wait a moment. Now we can see the warrior is actually in front of a computer, inside what appears to be a data center. This is much better. But multimedia processing doesn't end here. There is still much more.
Now it's time for voice generation. By the way, this is actually how the audio for this video was created, using this very tool. First, we look for a model to help us create the script, and we choose Gemini 3 Pro. We ask it to generate a conversation between Sol and Gustavo about Delphi. Upon receiving the response, we have a conversation with specific instructions that tell the model the tone, rhythm, and even if there should be size. Now we take this text, pass it to a text-to-speech model, and wait a moment for the AI to work its magic. After a short while, we find the attached file with the generated voice. Let's open the file and listen to the conversation. Hey, Gustavo, I noticed you were installing RAD Studio earlier. Are you seriously planning to use Delphi for the new module?
Yes, I am. You might be surprised, but for rapid application development, it's still a beast. I need to build a native UI quickly that connects to our legacy database, and Delphi is perfect for that.
I guess I always think of it as a language from the 90s. Doesn't it feel a bit outdated compared to using something like C# or Python?
The syntax is older, sure, but the ecosystem is very modern. It compiles just single file executables with no dependencies, and with FireMonkey, I can actually compile this same code for Windows, macOS, Android, and iOS without rewriting it.
I didn't realize it had that kind of cross-platform capability now. That actually sounds pretty efficient for maintaining a single code base.
Exactly. It's not the trendy choice, but when you need high performance and low memory usage without the overhead of a virtual machine, Delphi is still incredibly powerful.
What would follow this is the reverse process, sending the audio and obtaining the transcription. For transcription, we will use OpenAI's GPT-4o transcribe model, which is designed exclusively for this task. We just need to attach the file as we did before using the Upload menu. We select the previously saved audio and send the request. The model processes it, and after a few seconds, it generates the transcription text. It's a very simple process. Current models really do offer a vast array of functionalities. We have only shown a few of them here. Remember that it is the models themselves that provide these capabilities, so you only need the correct parameterization to get them up and running. Finally, the complete MakerAI suite includes tools developed 100% in Delphi, which are vital for creating professional production environments. Among them is RAG, Retrieval-Augmented Generation, technology that allows for context-based search. We feature a very powerful tool, knowledge graphs, operating in a hybrid RAG mode that combines embeddings with graph structures. We also have technology for agent orchestration, an essential tool for creating intelligent and autonomous workflows. And finally, components for creating MCP services with STDIO, HTTP, and SSE communication protocols, plus a proprietary one that allows connecting MakerAI AIs via the MCP protocol with DataSnap or RAD server. As you have seen, we've covered a lot of ground, from a basic chat connected to Ollama, through advanced capabilities like the code interpreter and multimedia generation, all the way to critical enterprise tools like RAG, knowledge graphs, and agent orchestration. MakerAI puts the full power of modern artificial intelligence directly into your hands, 100% natively in Delphi, with an ease of implementation that lets you focus on your business logic. I invite you to explore the code, try the included demos, and start taking your applications to the next level today. Thank you for joining us.